Hello, and welcome to information about factorials and permutations. Factorial definition. For any positive integer n, the factorial n and then an exclamation point is equal to the product of n times n minus 1 times n minus 2 times n minus 3 all the way down until you get to 1. So what does this mean? You ever see a problem that says 5 exclamation point, this means we're going to multiply 5 times 4 times 3 times 2 times 1, and that's going to get us 20 times 3 is 60 times 2 is 120. Now, you will also see this sometimes as like a division problem. So if you had a problem that said we want to calculate 5 factorial divided by 3 factorial, even though we could calculate 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, sometimes it's easier just to write it out to see what's going on. So if we write all these out here, what you're going to notice is that the 3's cancel, the 2's cancel, the 1's cancel. So we're just left with 5 times 4, which is 20. Now, as part of the definition, we also need to know that 0 factorial is equal to 1. The definition of factorial only works for positive integers. 0 is not positive or negative, but with everything in math, we always need to identify what exactly is happening when you look at a 0. So one of the definitions is 0 factorial is equal to 1. We will use the factorials a little bit later. So our next thing is looking at something called the fundamental counting principle. The fundamental counting principle says if we are given independent events, then the total number of options is equal to the product of those events. So for example, if you have 3 choices for dinner, and you have 2 choices for a side dish, and you have 2 choices for dessert, and 4 choices for a drink. How many different options would you have if you were to choose 1 dinner option, 1 side, 1 dessert, and 1 drink? Now, instead of listing out all the options, what we're going to do is we're going to say, well, what are the choices? For dinner, we have 3 choices. For a side dish, we have 2 choices. For a dessert, we have 2 choices. And then for the drink, we have 4 choices. So then we are going to multiply that whole thing out, and that's going to get us 6 times 8, which is 48 options. Now, when you were in geometry, you may have seen this using T-charts or like a branching idea, which you would have said for dinner, you have 3 choices. For a side dish, you have 2 choices. For dessert, you have 2 choices, and so on. But when these get too big, doing this little tree branch idea doesn't work out very well. So understanding this fundamental counting principle becomes an important way to solve problems. So our next thing that we're going to look at are things called permutations. Now, what is a permutation? A permutation really means let's take everything that we have and let's move things around as many ways as possible so that we're changing up the order, but the values are still there. So the most important thing that you need to know about a permutation is that order is important. Now, when do we have permutations? We will have permutations if you are talking about a phone number, if you are talking about your ID number, if you are talking about a locker combination. The combination 2, 12, 5 is different than the combination of 5, 12, 2, even though the numbers are the same. So what are some clue words you would see with permutations? Some clue words would also be the word arrange. How many arrangements can be made? Schedule. Order. Okay. Those are all important. So another example of a permutation would be if you had 6 classes in your schedule and we want to figure out how many ways can we arrange your schedule so that you have all 6 classes. So typically what happens is we're going to use that same idea of the counting principle. And we can say this is going to be your first period class, this is going to be your second period class, this is going to be your third period class, this is going to be your fourth period class, and fifth, and sixth. And so we know you're going to have 6 classes, but we want to know how many different ways can those 6 classes be arranged. Well, typically, how many different classes could go first? The truth is that all 6 of them could go first. So now what happens from here? When you go to fill in your second class, we know that there has already been one class that has filled in this class. So perhaps your math class went first period. That means of your 6 classes, there's only 5 left. Those are the choices for second period. Then we go through and we fill in a class there, and then we say, well, how many classes are left for the third spot? Well, 4, and then 3, and then 2, and then 1. So if we multiply all these together, and you can grab a calculator and multiply it that way, but you are going to have 720. There are 720 ways to organize 6 classes. So what that means is that if you and your friends have the exact same classes, then you should be really lucky. Now, some of you may be in classes where there were certain schedules that were set, and that kind of changes it a little bit, but let's talk about one example. So let's say that you are a junior, and let's say that you are in the sports academy. And I'm going to do this because this one I know the schedule for. So what do I know about this scheduling? So we're still going to talk about the classes first, second, third, fourth, fifth, and sixth period. Okay. So I know that some people are athletes and different things like that, but we're going to ignore that for just a moment. And we're going to say that we know you're still going to have 6 classes. So we know that. But what do we know? Well, in the academy, the classes are stuck in third, fourth, and fifth period, which means if you're in the academy, there's only 1 class to go third period. So that means our total number of classes here is going to go down to 5. And what do we know? Fourth period, there's only 1 class. Third period, you have to be in U.S. history. Fourth period, you have to be in sports medicine. And fifth period, you have to be in English 3. But what happens to our classes? Once we load the fourth period, that leaves our number of classes down to 4. There's only 1 class that can be taken fifth period, so that leaves our number of classes with 3. So how many classes are left for the schedule? Well, there are 3 options for first period, there are 2 options for second period, and there's 1 option for sixth period. So now, if we make this schedule, what do we end up with? Well, 3 times 2, oh, that only gives us 6. So if you are in an academy, what happens is the schedule of classes kind of limits, and so your options are reduced a little bit more. So let's do some other examples, maybe 1 or 2 more examples. So our next example is, I want to figure out if there are 15 people running a race, how many ways can we get our top 3 finishes? So we want to know how many ways, let's try that again. How many ways can the runners finish first, second, and third? Now, I know there's always conversations about this. It says so-and-so's faster, so we know they're going to finish first or second. That's a completely different discussion. So we are looking at first place, second place, and third place. Well, here's the deal. We have 15 runners. So with the 15 runners, realistically, all 15 of them could finish in first place. Now, once one of them actually finishes in first place, that means there are 14 runners who could potentially finish in second place. And then there will be 13 runners who potentially could finish in third place. And this will get us our total, which I'm going to go to a calculator and calculate 15 times 14 times 13, and that's going to tell us there are 2,730 ways for those runners to finish in first, second, or third. So if you look at it, the number of ways you're looking for, that's how many spots you have, and then you start with your total, and then you reduce from there. So hopefully this will help with permutations.